Consider two containers A and B containing identical gases at same pressure, volume and temperature. So let's assume in both containers A and B, as the pressure, volume, temperature are the same, we will assume the initial pressure is P0 and the volume is V0 with temperature T0. So the gas in container A is compressed half of its original volume isothermally, while the gas in container B is compressed to half of its original volume adiabatically. The ratio of final pressure of gas in B to that of gas in A is. So we need to find the value of pressure at B by pressure at A in the final state. It is given that in container A, the gas is compressed isothermally and the equation for the isothermal case would be P into V is constant. As the product P into V is constant and the volume is made half, from this we can conclude that the pressure in final state would be 2 times the initial pressure. Let us prove this. So as product P into V is constant, so P1 V1 would be equal to PF Vf, and Pf by P1 would be equal to V1 by Vf, and Vf is V1 by 2, so this is equal to V1 by 2. This comes out to be 2. So from this, Pf, which is the final pressure, is equal to 2 times the P1, which is the initial pressure. So whenever the gas is compressed to half of its original volume isothermally, the final pressure becomes 2 times the initial pressure. So PA in final state is equal to 2P0. Let us say this is equation number 1. In container B, the gas is compressed adiabatically, and for adiabatic case, the equation of the state is PV power gamma is constant. So from this we can write P initial, which is the P0, and initial volume V0 power gamma would be equal to the final pressure Pf into the final volume Vf power gamma. Therefore, Pf by P0 would be equal to V0 by Vf power gamma. And even in this case, the volume is reduced to half of its original volume. So Vf is going to be V0 by 2. So this would be equal to V0 by 2 whole power gamma, which is going to be 2 power gamma. So this implies Pf is going to be 2 power gamma times P0. So in container B, the pressure is multiplied by the factor 2 power gamma to the initial pressure. So the ratio pressure in container B by pressure in container A in the final state comes out to be 2 power gamma P0 by 2 P0, which is 2 power gamma minus 1. So this will be the ratio of pressure in container B to pressure in container A in the final state. So the answer is option A.